Okay, so this is my third video, and I'm glad to see the responses from the people regarding my previous videos. And they have asked me some questions as well. So I would like to answer them first before I address the issues I raised in video 2. So the very first question is regarding forecast accuracy. Some people have asked why forecast accuracy too high is bad. In my video 1, I mentioned that forecast accuracy too high is also not good. It seems weird to you, but I would explain why I said that. In order to improve your forecast accuracy further than the level you regularly maintain for your business would need some investment, would need some spending in terms of buying new software, upgrading the current software, and hiring more people that can do market analysis for you. So all these activities would need some spending, would need some investment. So before you go and make those decisions, you should know what forecast accuracy level can get you desired results in terms of inventory turns, in terms of on-time delivery, in terms of customer order fill rate, and so on. So you should know those cutoff points, meaning forecast accuracy versus inventory and on-time delivery and customer order fill rate. So those cutoff points you should know for your business. And based on my previous experiences, proper inventory stocking policies, meaning Kanban, safety stock, min-max, and so on, can help you get the same results, same desired results that will be less expensive than spending money on improving forecast accuracy. So the bottom line is, if you can improve your forecast accuracy too high or maintain too high, probably 90 or 95%, is good. But at what cost you maintain it? At what cost you achieve it? That's important. I hope you got the message. Okay, so now let's move on to the second question. And this is about inventory turns. The question is, inventory turns, how much inventory turns we should keep? So another very generic or common question. So there's a misconception among people that they think they should keep improving inventory turns. It's not true. The higher the inventory turns, the less number of days of stock you will have. So in some cases, you may not be able to support additional customer orders. So you will be compromising on revenue. So at one hand, you will be reducing inventory dollars. On the other hand, you will be losing money because you won't be able to support additional customer orders. So let's suppose you have 2 weeks of stock on hand and you have a supplier lead time of 2 months or 3 months. Okay, so that's a very risky scenario. That limits your ability to support some orders on top of the regular forecast. Okay, so the point I'm trying to make here is all parameters are interrelated. So if you make a decision, don't make in isolation. Otherwise, you will be optimizing just one variable, but your overall cost of operations will go up. So when you try to model or simulate your problem, try to find the effect of one variable over other variables. That will give you the optimal result. Okay, I think you may be interested to know how we can calculate those cutoff points, meaning the cutoff point between one variable versus another variable, meaning forecast accuracy versus on-time delivery, inventory turns. In my future videos, I will demonstrate in detail, I'll explain in detail how we can calculate those cutoff points. Probably in my 4th or 5th video. Okay, so keep watching my videos. So now let's move on to second part of this video, where I will explain or address the issues I did in video 2. So be with me, stay with me. I will be sharing my screen. Thank you. Okay, so this is second part of this video, and if you remember, I went over 4 cases in my previous video, meaning video 2, and we found out that in case 3 and case 4, when the demand was going up in period 2 compared to period 1, then the safety stock that we calculated using safety stock formula was not enough to support demand for period 2. So meaning that safety stock formula in those cases might result in a stock out situation. So at the same time, I gave you one exercise and I asked you guys to see when the demand goes down how safety stock formula would behave on those cases. Okay, so I'm gonna go over this exercise right now. I don't know if you guys have enough time to do that, but I will go over right now. So if the demand in the second period goes down, meaning that the demand has a downtrend, so lead time demand for period 2 will be lower than the lead time demand for in period 1. Okay, so LTD2 will be lower than LTD1. So in other words, if you carry inventory, okay, at least equals to period 1, then your inventory will be enough to support demand for period 2, because demand for period 2 is lower than demand for period 1, right? So let's do it mathematically and see how we come up with the results. Okay, so LTD2 is lower than LTD1, right? So we can write LTD1 equals LTD2 plus delta D, and we are assuming that standard deviation of demand is not changing. Okay, just to make things simple, just focus on forecast changes. So I'm assuming that standard deviation of demand for period 2 equals the standard deviation of demand for period 1. So it won't make a big difference. You can also use a variable standard deviation. Okay, result would be the same. Okay, so we know this inventory formula. Inventory for period 2 would be equal to lead time demand period 1 plus safety stock for period 2, right? So we know that LTD2 is lower than LTD1, so we can substitute this one into this equation. Okay, and then you will see that inventory for period 2 will always be higher than lead time demand for period 2. Okay, so let's solve a numerical example. Okay, so this is the data. So period 1, week 1 to week 5 through week 5, period 2, week 6 to week 10, and you can see that the demand in period 1 is higher than the demand in period 2. Okay, so and we set the same hypothesis. Target inventory under demand system is sufficient to support demand in period 2. Okay, so if the lead time demand comes higher than the inventory for period 2, then this means that we need to reject the hypothesis, and the inventory won't be enough to support the demand for period 2. Okay, so let's put in the equations. So lead time demand for period 1, we need to sum up the demand from week 1 to week 5, and demand for period 2, you need to sum up the demand from week 6 to week 10. It's 150, and you can calculate standard deviation for period 1 and standard deviation for period 2 using the demand shown in this table. Okay, and you have the safety stock formula. So I'm using safe service level for 99%. So if you go to normal table, and you will see that the V score will be 2.326 against 99% service level. Okay, and we know that lead time is 5 weeks, and also the standard deviation is 14.14. We put in the safety stock formula, we get the safety stock 73.55, and we put in the inventory equation. 400 is the lead time demand for period 1 plus safety stock, and you will get 473.553. As you can see that the inventory for period 2 is 473, is much higher than lead time demand for period 2, that is 150. So more than enough to support the demand for period 2, right? So in other words, if we had no safety stock, meaning 0 SS1 arrow 2, it won't make a big difference, right? So in that case, inventory will be still higher than the demand for period 2. Okay, so we can say that no safety stock needed, and safety stock formula in this case will result in excess inventory. Okay, so that's the finding of this exercise. So what we learned from overall exercise 1 and exercise 2. So we learned that also from case 3 and case 4, we learned that when the demand has an uptrend or the downtrend, we need to be very careful when we use safety stock formula. So when the demand has an uptrend, it may not give you enough safety stock to support the demand for the next period. And when the demand has a downtrend, it might result in excess inventory. Okay, and it will result in excess inventory, which we have seen. Okay, so that's the finding. Okay, so also I gave you another exercise in which I asked you to use lead time forecast instead of lead time demand and see how it affects the safety stock formula. And same exercise is basically my proposed model. Okay, so in my proposed model, I am using lead time forecast for the next period instead of lead time demand for period 1. Okay, in the inventory formula. So this is listed here. So instead of LTD1, I'm using lead time forecast for period 2, and safety stock formula same, no change. Okay, so we assume that you have a forecast software and you can calculate the forecast for the next period, and when you have the forecast software, you can also know the trend, right? So forecast software can let you know if the trend is up or trend is down. Okay, hoping that you know how to use the forecast software. Okay, so in that case, LTD F2, if there is an uptrend, will be higher than LTD 1, right? Because you have an uptrend, and the formula will capture that. So let's go over. Let's move on further and solve an example. Okay, so we have period 1, week 1 to week 5, and period 2, week 6 to week 10, and we have a demand for period 1, and we have a demand for period 2, and we use the forecast software to calculate the forecast for period 1 and forecast for period 2. As you can see that the forecast for period 2 is higher than for demand for period 1. Okay, so when we put in the inventory formula, LTF2, so you need to sum up the forecast from week 6 to week 10, 185, and safety stock formula. Also you need to know the standard deviation of demand for period 1, you know that, and Z-score against 99% service level, and you have lead time for period 1 as well as period 2, 5 weeks. So you get total inventory 219.49. Okay, and we know that lead time demand for period 2 is 195. How do we know that? You can just calculate here, lead time demand. So that should be equal to 195. So this means that your total inventory that you calculated is higher than the demand for period 2. Okay, so in other words, inventory for period 2 will be enough to support demand for period 2. Okay, so meaning that our proposed model is working, and for the most part is addressing the issue that we highlighted in case 3 and case 4. Okay, so what is the summary? What's the takeaway? So we have seen the shortcomings of demand system and forecast system, okay, in my previous video, from case 1 to case 4. Okay, so 4 cases presented in video 2 make it very clear that if the lead time demand is moving up in the next period, the traditional safety stock won't be sufficient. I already talked about that. Besides demand increase, if the standard deviation of demand is also increasing the next period, okay, then more inventory will need to carry, right? It's not a rocket science. Just put in the inventory formula. You'll see that when you have two variation here, delta D and delta S, and demand is changing, and also standard deviation is changing. So when you have demand from week 1 to period 1 to period 2 is changing, and standard deviation is also changing, then you need to carry more inventory. Okay, so it won't be, I don't think it will be very difficult for you to understand that. Okay, so proposed model address the issues that we raised in case 3 and case 4. In the case of demand uptrend, we know that LTF2 will be higher than LTD1, so the resulting inventory will be higher, and that will avoid the situation of stock out. Okay, avoid the stock out situation. So as a result, okay, so your ability to support the demand in period 2 has been improved. Okay, so we are done with my proposed method and also the exercise that I gave you in my previous video. Okay, so one more exercise for you. In my above proposed method, try using a standard deviation of forecast error instead of a standard deviation of demand. Okay, so what I'm asking you in this formula, okay, just keep LTF2, but instead of a standard deviation of demand for period 1, try using a standard deviation of forecast error. Okay, and see what results you see. Okay, and how do you compare from this method to the exercise that I'm giving you. Okay, so thanks for watching, and please don't forget to subscribe for more videos. So in my next video, people have asked me to go over end-to-end supply chain process and go over some control points. So I am thinking to load my next video on the end-to-end supply chain. Okay, and what are the issues that companies faces, and what are the shortcomings. I will also go over in end-to-end supply chain processes. Okay, so based on my experiences in my different companies, what are the pain points, okay, in the end-to-end supply chain process that I have experienced, and that you should be very careful. Okay, so hope to see you in next video.